My name is Frederik Vanhoutte, and I'm here as a creative coder. And this evening there will be several talks focusing on the science of the pieces that are being exhibited. They asked me to talk more about the technology side of it. So I'm not going to talk oceanography or meteorology here at this work of Anadol, but I'm going to talk about what's behind that piece. And that means that I'm going, like in 15-20 minutes, give a brief overview of if people are talking about creative coding, what is that about? If we are talking about generative art, is that the same thing? Is that something different? But the first, you're probably wondering why I have this. Thing is, I wasn't sure if any people would show up, and I would be standing here for 20 minutes without an audience, so I had to entertain myself. The advantage of doing coding is if you have to do a presentation, you are not using PowerPoint, so you can do whatever you want. But anyway, press start to continue. I first want to talk about a term that I don't like, or at least that I don't think makes sense, and that's the term computer art. A lot of the things you see here involve computers. And people talk about computer art, and it's a bit strange, because you never hear somebody talk about brush art or chisel art. The computer is a tool that we are using, and maybe the confusion is that the computer is the tool, but it is also the canvas, and often it's the entire medium, and never escapes the computer, although that isn't necessary. But the main reason I don't like the term computer art, besides it being very, very generic, focusing on the tool, is that it's rarely used in a good sense. It is often used in a way that you say, okay, the computer is taking away from the art. It's a machine generating thing. There is no human side to it. And that's a bit strange. It's a sentiment. I think not many of you have that sentiment very strongly because you're here at this event. But if you would go to classical curators, to galleries, chances are, if they hear that computers are involved, it's not fine art with capital F and capital A. And I think that's strange, because these people do consider literature to be an art. And yet, I mean, typewriters and word processors do not generate literature. And it's the same with computer art. It's never a machine that is generating what is coming out of it. It's making the image, but it's never a product of only a machine. And even now, with this evolution we are seeing in machine learning, artificial intelligence-inspired art, it is still a very human creator who is making something. Although he's not making a painting, a picture, he's creating creation. So this very broad term, computer art, that can mean a lot of things. You have people who use computers as brushes, you have people who use computers to do all kinds of things. I introduced myself as a creative coder. I am not a professional creative coder, I am a hobbyist. It's a pastime for me. Professionally, I'm a medical physicist. I work as a radiation expert in a radiotherapy department at the University of Ghent. But this is my pastime, and I use coding, programming, to do weird things. And I am in a very advantaged position that since it's a pastime, it's a hobby, I can do whatever I want. They don't have to fit a goal. They don't have to fit a certain aesthetic, a brand. So I can pretty much abuse sources. Because the creative in creative coding often means using things you find creatively. And this is a tool set that is available for animators to create characters. And they have a huge range of parameters that go from baby to old person. You're not supposed to mess around with it like this, but still, why not? The tool is there. I use source material creatively, images closely tied to my profession, but my main passion is geometry. And I like shapes like this that pop out of nowhere. Let's see if I can freeze the generation of the shape. You can create this shape by hand, you can sculpt it. But for me, it's not the shape that matters, it's the evolution. It's these bubbles that are popping up, these particles that are generating these shapes are being regenerated again and again and again. And the only medium, the only way to do this is by programming it. If you do this by classical animation, it would work. You could do it. It would be beautiful. I mean, look at the work of Disney. When they did hand animation, they did beautiful procedural flames and water. But still, this is within the skill set I have, and this is, for me, obtainable. So that unlocks, for me, creative coding. I am a physicist by education. So another fun thing, another creative use is to use all these laws and things you know, which are actually meant to reflect reality, to be a simulation, and just take them into whimsical, strange areas where you use these laws and you just throw away the parts you don't like attenuation of light. Let the beam continue at infinite. You don't like the other colors of the rainbow, only use 3 of them. It's okay. So before I go to the generative part, there is something I have to talk about, since we're here at the art and science, and we often talk about being at the intersection of art and science, as if these are 2 very separate areas, and there's one point where they reach, and we are at that intersection, and that the intersection is getting really, really crowded, and you don't find any parking space, and you go back home. Because we have this image. We have this image of there's a part of our brain, there's a part of ourselves that is very artistic, that is free of constraints, and it can do whatever it wants, and it's emotionally strong, and it has bonds with humans. But that's not, by definition, not rational. It might be not always taking the right decision. And on the other hand, we have this rational part, which is fact-based, which is science, which is actually not that good in these human kind of things, which is a bit strange, because the very definition of rationality is that you would take into account what reality is. You cannot just discard certain parts. And for a very long time, these parts have not only been seen next to each other, but even seen as opposing to each other. And a very good example is this verse of the epic poem Lamia by the Romantic poet Keats, who says, "Do not all charms fly at the mere touch of cold philosophy? Philosophy, natural philosophy, is science. There was an awful rainbow once in heaven." Words change meaning. Awful, we would now say awesome. It was full of awe. This was this amazing thing in the sky. But now we know her woof. We know her texture. She is giving in the dull catalogue of common things. Science has looked at this rainbow, has unraveled the threads, has put this in a book together with all the other dusty subjects, and has lost all its shine. Philosophy, science, will clip an angel's wings, conquer all mysteries by rule and line, empty the haunted air and gnomed minds, unweave a rainbow as it is erewhile made, the tender, personed Lamia melt into a shade. So this bright light of science is not brightening the world, it is removing the spirits and the gnomes. The whimsical Lamia is removed from the world. You have to be a romantic poet to lament that, because Lamias in Greek mythology eat children, but okay, it's maybe a bad thing that they're gone. So this is a sentiment that's quite strong. Science is taking away beauty, and it's replacing it with facts and things. And in fact, maybe that's not entirely false, because we have this kind of wonder. Let's see if I can turn up the sound a bit, because wonder needs to be heard. That didn't go well. Where people are amazed by the rainbow, very loudly so, except here. I'm not going to do the sound effects. Doesn't matter. There he is. And we replace that wonder, that amazement, we replace it by this. And okay, there's some beauty still in there, but behind the screens, this is just an excuse for your physics teacher to give you this. Everything becomes angles and goniometry, and that's the beauty of science, and this is the kind of thing that you have to replace the rainbow with. So that's a kind of a loss. But I don't agree with that. I think we have some catching up to do in that image. And we are here, and this event is proof of that. We have art and science. It is not as much an intersection. It's an area where these 2 endeavors are coming together. Nothing we do is pure art. Nothing we do is pure science. Even where they communicate, it's not only tech that makes them communicate. Every scientist has a part of an artist's soul, and every artist has, in its way, he's looking to achieve something, to give a message, has a scientific method behind his practice or her practice. Science has the habit of having these kind of world-changing ideas, but behind the screens. It takes some time before they arrive into popular culture. It's a bit strange. We started in a flat world which was limitless, which was filled with spirits, which was filled with things communicating with each other. And it was a very complex place, and you needed to tell stories to find your place in that world. And throughout history, especially in our Western history, this infinite plane became this bounded sphere. And at the end of the 19th century, we had this clockwork universe, a universe controlled by thermodynamics, by steam and brass, by electromagnetism, by electricity. And everything was very, very predictable. And you had this clockwork. And the idea there was that we are here and now, and we have a certain state, and that state is stable. And next moment, we have a different state. We have this, what in physics is called quasi-static. We are moving from one static state to another. And okay, there are things changing in between, but the focus is on the now, on this state. I want to measure temperature here, I want to measure mechanical force there, and then I know how this will evolve tomorrow and the day after, and everything becomes predictable. And then, in this first half of the 20th century, quantum mechanics came, and undoubtedly other people will talk about quantum, and undoubtedly people will use that in their art. And that is actually undermining already certainty. But there is also a second revolution in the 20th century. The second half of the 20th century, we get mathematicians that are starting to solve so-called nonlinear systems, difficult systems that we have avoided to fix because we didn't have the mathematics. And we get something called chaos theory. And what chaos theory says that, okay, quantum is nice, but you don't even need quantum. You have systems which are perfectly macroscopic, which are perfectly mechanical. You know all the laws, but there is no way you will be able to predict what happens. Although they are completely deterministic, you will never predict. So we lose predictability. And now, beginning 21st century, we have evolved to a worldview that is much closer to the infinite plane filled with spirits communicating, where time and space are these very strange quantities. So I want to go back to this one line that Keats meant as prerogative, where he said, we conquer all mysteries by rule and line. And for him, rule and line are rigid. And this is actually, this fits the physical theory of his age, of the 19th century, the clockwork universe. If everything is rule and line, there is no freedom. But rule and line is a perfect way to introduce the so-called generative art. Generative art is separate from computers. It's separate from creative coding. You don't need computers to do what is called generative art. And as an example, and of course, it's a very, very small example. I cannot, in 20 minutes, do the history of generative art any honor. But one way you could use computers is to say, I want to make a certain image, and I'm not very good with printing, and I don't like Adobe, they don't want my money, so I make my own code to make some kind of tiny drawing system. And let's see if I can draw something. And I want to make this kind of isometric pop art kind of thing. Woohoo! Hey, bar. With a bit of practice, instead of making a presentation you have to give to the people, but with a bit of practice, you can make simple figures, and you can make some more complex figures that get worse the longer you look at them. And if you're very committed and very serious, you go on, and if you make this thing your life work, you do this. But that's not what, for me, creative coding is. I don't want to use the computer as a paintbrush. I want to use it as a system that works for me. So I have to take a step back. And instead of trying to invent a system that draws like me, and have it generate infinite variations, there's no structure in it. These are momentarily beautiful. There's an infinite amount of these, but that's actually totally irrelevant because they all look alike. So even if there are an infinite amount of these, we get bored of them. Generative artists sometimes fall into the trap, yet every piece is unique. Every label on this Fanta is different from the other. And you look at them and you say, well, they're the same. So it doesn't work that way. I cannot make the computer work the same way as me. Do I really have to shout above that one? Ooh, go hard. So for generative, you reverse it. You start inventing rules. You make a system that creates. Instead of creating something, you make a system that creates. You don't need a computer. You need to take a notebook and you make lots of indices. And I can generate shapes that have structure, which have coherence, which fit this. And the reason they fit it is because the system behind the screens is making something spatial, something that is real, that is behind the screen. This is not something that I use when I would draw this by hand, but in my head, I have this spatial structure in my head. How would I otherwise draw this thing? And then this you feed into other systems and can, for example, generate plots. Now, we are here at Bosphorus by Refik Anadol, and that's a data visualization. And the data visualization is of measurements done at the Bosphorus, this narrow strait, where they do measurements by radar, by satellite, of waves, of wind speeds, all these kind of patterns. They take a point every 30 minutes. And this is the presentation. And okay, this is honestly very informative, but this is also the typical way that we present the world. And actually, when Keats is talking about the rainbow, then this is the prism. You have this beautiful sea surface, this ocean. And if you go to the sea, it's impossible not to appreciate the complexity of this surface, the continual movement. Everybody always stands and look at it. And if I go to the sea, it's always an Instagram post, so that means something. And he has this data, but in this data, the sea is lost. And what he has created is actually a visualization of this data. What is shown there is controlled by what is being measured. It looks like an ocean surface, but it's not an ocean surface because every point that is moving is 30 minutes apart. The scale that is moving, this is the entire Bosphorus. But what he did is from this abstract data, which does not represent how it looks, he reclaimed the ocean. He said, this data represents the ocean. I want to show you the ocean. And he reclaimed it from there. And that is what is in the heart of generative art. Thank you very much.